Hello and welcome to High Voltage Engineering. We'll be talking about conduction and breakdown in liquid dielectrics. Uh, in this in this topic, we'll be talking about conduction and breakdown in pure liquids. Okay, so let's go to the slide. So we'll be talking about conduction and breakdown in pure liquids. When a low electric field less than 1 kilovolt is applied, the conductivities of 10 to the power minus 18 to 10 to the power minus 20 mho per centimeters are obtained. So when low electric fields are applied, this conductivities of a very low conductivities are obtained. That is the conductivities are low. That means the resistivities are high. Okay, so these are probably due to the impurities remaining after purification. However, when the fields are high, that is more than 100 kilovolts per centimeter, the currents not only increase rapidly but also undergo violent fluctuations which will die down after some time. Okay, now this graph shows the typical mean value of the conduction current in the hexane uh, at high fields. Okay, this is the condition nearer to the breakdown. So you have the electric field and you have the conduction current. Okay, so beyond this, after this field as it increases, you have these conduction currents also increase. But beyond this, to this point, there is no conduction current. So this is the region uh, which is which is told about in this point number one. Okay. So in the next slide, it is we are much more this figure is much more zoomed of the previous slide. The previous figure, this one is a very it had a lesser amount of detail. Now it is with a more amount of detail. Okay, this figure is drawn starting from very small currents and the current electric field characteristic. This curve will have three distinct regions as shown. You have three distinct regions as ionic region, saturation region, and field aided. Okay, at a very low field, the current is due to the dissociation of the ions. That is in the first part, the ionic field. Okay, with the intermediate field, the current reaches a saturation value, which is called the saturation field, and at high field, the current generated because of field-aided electrons emission from the cathode that get multiplied in the liquid medium by Townsend type of mechanism. So this thing increases exponentially, almost following this Townsend kind of equation. One electron creates two more electrons, and that two electron will create two more electrons, and so on. So this becomes an avalanche breakdown, as we have talked seen in the gases. Okay, the current multiplication also occurs from the electron generated at the interfaces of liquids and impurities. The increase in current by these processes will continue till the breakdown occurs. The exact mechanism of the current growth is not known. However, it appears that the electrons are generated from the cathode by field emissions of electrons. The electrons so liberated can be multiplied by a process similar to the Townsend's primary and secondary ionization in gases. As the breakdown field is approached, the current increases rapidly due to a process similar to the primary ionization process, and also the positive ions reaching the cathode generate a secondary electron leading to a breakdown. So this is the region that we are talking about, that is similar to the Townsend's primary and secondary ionization process. The breakdown voltage depends on the field, gap separation, cathode work function, and the temperature of the cathode. In addition, the liquid viscosity, the liquid temperature, the density, and the molecular structure of the liquid is also influence the breakdown strength of the liquid. Okay, so we'll be talking about the conduction and breakdown in pure liquids. We'll be talking about the process. What is the process of breakdown of the conduction of pure liquids? So we can see the breakdown process of the pure liquids. So as the breakdown field is approached, the current increases rapidly due to the process similar to the ionization that we have talked previously in the Townsend kind of process. Okay, so again, it's a recap that the breakdown voltage, it depends on the field, the gap separation, the cathode work function, and the temperature of the cathode. So lastly, the type of breakdown process in pure liquid called the electronic breakdown involves emission of electrons at field greater than 100 kilovolts per centimeter. This emission occurs either at the electrode surface, irregularities, or at interfaces of impurities and liquids. These electrons get further multiplied by Townsend's type of primary and secondary ionization process leading to a breakdown. So we have seen that the characteristic of pure liquids which has very low to zero impurities, the way the breakdown occurs in the liquids at a high electric field becomes almost similar to the Townsend's uh, the Townsend's equation of gas breakdown, the breakdown in the gases. Okay, so it starts with a we slowly when we increase the electric field, it has a very low value of conduction current, which is almost negligible, and then it reaches to a saturation point, and then the Townsend's breakdown occurs and the avalanche breakdown creates. Okay, so this is the characteristic and the breakdown of pure liquids. Okay, now in the next class we'll be talking about the commercial liquids. So this is the end of the class. Thank you.